I'm so glad that you're excited about manipulatives and you wanted to check out the base 10 blocks. Welcome. All right, well, we are going to start with this first unit size. This is equal to 1. If I took 10 of these and I put them all together, 1, 2, 3, 4, 6, 7, 8, 9, 10, that's a rod in base 10 blocks. And it's worth 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One of the really great things about base 10 blocks is that when you keep tens together, or a few single ones together, it's very easy to see how much you have altogether, because then you can just kind of skip count by tens, 10, 20, 30, 40, 41, 42, 43. And so visually it's very easy to see how many are there compared to this, right? A pile, it's difficult to tell how many there are altogether. But when you understand principles for base 10 blocks, that helps you understand easily about how this system works. All right. So another thing about this rod is if you look at it this way, you can also think of it as measuring something linearly. So this is worth 10 units, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I put another one on the end, then I know that's worth 20 units. And so you can kind of measure that way as well. If I took 10 of these rods and I put them together, so they're all nice and even, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10 rods all together make a flat. I could count them individually, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But since I know that a rod equals 10, I could even skip count. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So I know that a flat equals 100. I can also think of it as an array. So I can see that there are 10 rows and there are 10 columns going this direction. So 10 by 10. When I think of it that way, I can also think about area. This is the length, and this is the width of my area. It's as if I'm multiplying this side, the number of parts on this side, by the number of parts on this side. 10 times 10 equals 100, and that is measuring this whole area. You measure area in units squared. And the reason that is you have two dimensions, the length and the width of something, in order to find the area. So it's measured in units squared. 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now I have a block. And because I know each of these flats are worth 100, I can skip count by 100. 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. A block equals 1,000. Now, when I think about this, I think about volume, because I can see that volume is the space that something occupies, or the space that something takes up. And so It's interesting because it's measured in cubic units. So we have the length, we have the width, but then we also have the height. So we're looking at 3 different dimensions in order to measure the size. And so it's measured in cubic units. Another really great thing about using these base 10 blocks is they coincide with our number system. And so I can put out a few of the single units, and I can take some of the rods, and I can take a flat. And I can easily see the number of units that I have altogether because I know this equals 100. I know each of these equal 10, 10, 20, 30, 40, and then there's 3 single units, so 143. I have ones, tens, and hundreds that I can represent with these base 10 blocks. I can even think about it in terms of decimals, which is really cool. So this single unit, I know there's 100 of these in my whole. And so if I have 1 out of 100, then that's 1/100th. I know that there are 10 single units in the rod. And there are 10 rods in my whole, which is the flat. And so I have 1 out of 10, or 1/10. So what if I did that? So this is my 1, this is my tenths, and this is my hundredths. 1 and, the decimal, you always say and where there's a decimal, 23 hundredths. 1 and 23 hundredths. So you can even show